So, where was I? Oh, the ADAS model. So we've got this real output, and we have our price level. And we know that we're at some full employment level of output. We've got some price level that exists here, whatever this gas, we'll just call it 100 because it's just a nice round number. It's easier than having PL1 or whatever. And what we had in the 30s, we had a decline in aggregate demand. All right. And so we should have seen a decrease in prices, which is exactly what we saw. We should have seen a decrease in output, which is exactly what we saw, and an increase in unemployment. Only the problem was, and for a variety of reasons that we understand now that we did not understand at the time, aggregate demand, we should have seen this increase. What should have occurred is we should have seen this increase in short-run aggregate supply doing this, returning us to this full employment level of output, and just doing so basically at this lower price level. For a variety of reasons, that did not happen. Some of those reasons are that the Federal Reserve engaged in a monetary policy that was actually restrictive rather than expansionary. But at the time, people didn't know that. And so they assumed, well, maybe there's something wrong with the model. And so you had a guy by the name of John Maynard Keynes came along and said, you know, the problem with this is not that the short-run aggregate supply curve is going to increase or decrease to return us to these full employment levels of output. It will eventually happen, but what he said is that in the long run, essentially, we're all dead, right? In other words, we have this decline in aggregate demand rather than waiting for short-run aggregate supply curve to increase. Why not just go ahead and do something that makes aggregate demand increase again, right? So basically, he said we should do something completely different. It's basically a different model that's based more upon aggregate expenditures and inventories rather than on aggregate supply, all right? So this Keynesian model has as its focus aggregate demand, all right? And manipulating aggregate demand. So you'll recall that output here, right, our GDP is equal to our C plus gross investment plus G plus X minus M. And in essence, what Keynes said is that if you really kind of think about it in a way, these aggregate expenditures are equal to aggregate demand, and eventually these things are going to be equal to output. Firms aren't going to make stuff that they can't sell, basically, is what he said. It doesn't make sense for them to do that, right? So what he basically said is that if aggregate expenditures are greater than output, this means that firms are going to increase output. If aggregate expenditures are less than output, firms will decrease output, right? And he said that if these aggregate expenditures are equal to output, firms will do nothing. Right? They're not going to expand. In other words, he said, basically, when you get to a point like this, it's possible you can say, hey, aggregate expenditures are equal to output. Inventories aren't increasing or decreasing, therefore there's no point in doing anything, right? So what you have happening here, You see aggregate expenditures are larger than output. People are buying more than was being produced. Inventories are declining. That's a signal to firms, I need to make more stuff. If you have aggregate expenditures less than output, here's the stuff you're making, here's what people are buying, inventories are increasing, that's a signal to firms, hey, I'm making too much. All right. And here, there's no change in inventories. That's a signal to firms that they're doing the right thing, right? So the assumptions of the Keynesian model are pretty simple, right? There's some level of output. Where y is equal to yf, right? Basically, there's some full employment level of output is basically what he said. So far, that's not that big of an assumption, right? That's always true. Here, though, we saw wages and prices are flexible. Keynesian model says that's not true. He says wages and prices are actually inflexible, especially if they're going down. It's easier to raise prices. It's easier to raise wages. It's hard for firms to cut prices, and it's really hard for wages to go down. People don't like that very much. It's a very, very difficult thing to do. So he said over here, well, you've got this decline in aggregate demand, and we know how this gets fixed. The short-run aggregate supply curve changes. Right? You have all of this unemployment. That unemployment puts downward pressure on resource prices, i.e. wages, and nominal wages decline, despite the fact that the real wage stays the same. The nominal wage is declining. And he says, I don't think that happens. People aren't going to take too kindly to that, right? So let's look at this Keynesian model in detail. And to look at this Keynesian model in detail, we need to look at the behavior of each one of these guys. All right, so let's look at the consumption model first. What he says with consumption is that consumption is a function of income. All right. Basically, as income increases, consumption will increase. Okay. But there's two different components to this guy that are important. We have what's called autonomous consumption. This is the consumption that occurs when income is equal to 0. Right? Even if your income is 0, you still have to eat, you still have to have a place to live, etc. Basically, Keynes says, even if your income is 0, you still have to consume. The other one is called this marginal propensity, bless you, to consume. EMPC, right? What this guy is that he is the change in consumption divided by the change in income. So what he says is that when people's income goes up by $100, their consumption goes up by some amount, whatever that amount is. Related to this, you have the marginal propensity to save. This is going to be the MPS. This guy is our change in savings divided by the change in income. Okay? So this is after-tax income. And there's essentially only two different things that you can do with your money after you pay your taxes, right? So here's your income. You're going to pay taxes on it. That leaves you with your after-tax income. And there's only one thing you can do. You can consume it, or you can save it. All right, I mean, what else could you do with it? So what this says is that the MPC plus the MPS is going to be equal to 1. Right? Which means the MPS is equal to 1 minus the marginal propensity to consume. So let's look at what this looks like graphically. And before we draw that, let's look at a 45-degree line. So here's X, here's Y. You have a 45-degree line here. The reason we're going to have this 45-degree line is that this guy tells us where Y and X are the same. And this is true not for economics, this is just true because of math. All right? So if you have some function that can do anything, wherever this guy crosses this 45-degree line, the X and the Y have to be equal. Right? That's not true here. Y2 and X2 are not equal to each other. Right? It's true here. X3, Y3, right? All it did was make a box. It's just a square, right? This is a square. And a square has the same side on all, it's the same value. All of the sides here are the same, right? That's what a definition of a square is. So that means this side of the square and this side of the square are equal. All right? Same thing over here. This is just a square. All right? Y3 and X3 are the same if it's a square. But you can see here that that's not true for this guy. This black side is not the same length as this guy, right? It's a rectangle. So we're going to draw this 45-degree line so that we can know where these guys are equal to each other, because that's going to be important. So if consumption is a function of income, which one goes where? Consumption on the y-axis or consumption on the x-axis? X-axis. So here's our consumption on the y-axis, here's our income on the x-axis. Right? And we got this 45-degree line. And we have our consumption function, and here's what our consumption function looks like. All right? So here's our consumption function. And remember, this guy tells us how much people consume as a function of income. And remember, this is just a line, right? What's the equation of a line? Y equals mx plus b, right? You thought when you were in high school you weren't actually going to have to use math again. You're going to have to use math in life, not just in economics and a lot of different things. This is the slope. Remember, this was the y-intercept. Right? That's all that this guy is. Except that we're going to call autonomous consumption A. We're going to call this marginal propensity to consume B. So we've got some level of autonomous consumption here. Bless you. So here's our autonomous consumption. Remember, this is the consumption that occurs when income is equal to 0. And when people get income, they increase their consumption at some particular rate, whatever that rate is. It can be any number that you want it to be. Right? Let's look at what's happening here at this point right here. Consumption is equal to income, right? There's no savings. There's no dis-savings. Okay. Let's look at what's happening in these values less than y1. Let's just choose one. I'll just call this one y0. We see here at y0, we're consuming some amount CO. And what we have happening here, we've got y0 is less than CO, right? Our consumption is larger than our savings. So all of these values in here, consumption is larger than income, we have dis-savings. How can consumption be larger than income? What are people having to do? They're having to go into debt. They're borrowing, right? So they're either borrowing money or they're drawing down on their savings, and one or the other, right? How many of you guys are borrowing money to come to school? I mean, you're borrowing any amount. You're here, right? Your consumption is up here at CO. Your income is here at YO. You have dis-savings occurring within this part right here, right? So here we've got our dis-savings. And as income goes up and up and up, consumption's increasing, but it's increasing at a less rate than income's going up. Right? Because remember, marginal propensity to consume and marginal propensity to save are equal to 1. So the slope of this guy has to be less than 1. Over here at, say, y2, it's the exact opposite. Here we see consumption is less than income, right? So at y2, income is larger than consumption. We have savings. And you can see what the size of that savings is going to be. This guy in here, right? As income goes up, this guy gets larger and larger and larger. What would happen if the marginal propensity to consume was greater than 1? Take that, take that question and move it back about 2 or 3 days. People in the video can fast forward. Ooh, what's the answer? Okay. So let's look at an example here. Let's suppose our marginal propensity to save is, say, 0.8. So here's our income. Here's our consumption. Here's our 45-degree line. Here's our consumption function. And you can assign any number that you want to here. I mean, you can make it anything. Make this guy say 30. So we've got some consumption function here. Equal to 30 plus 0.8y, right? When income is equal to 0, when y equals 0, 0.8 times 0 is 0, consumption's 30. That's what this guy says. Autonomous consumption is equal to 30 bucks. People are spending $30 per day, per week, whatever it is that you want it to be. It can be any number that you want it to be. We've said here the marginal propensity to consume is equal to 0.8, right? As people's income goes up, every dollar that goes up, their consumption goes up by 80 cents, or every single 100 bucks that they go up by, consumption goes up by $80, right? That's just the slope of this line. So you take any 2 points on here, they can be any number that you want it to be. Y1 plus 100, C1, C1 plus 80, right? It's just the slope of this guy. That's all that it is. This guy right here is the slope of the consumption function. Right? Remember, what's the equation for slope? Rise over run, right? You got to rise before you can run. You guys remember that? Here's your change. Well, it's changing by 80. Here's your change in the running, right? It's changing by 100. 0.8. Questions before we move on? It's just the slope of this. This number can be anything. The slope can be anything. So you could have the slope be 0.3. So in that case, it would look like this. So here would be income. Here would be consumption. Here's our 45-degree line. Consumption is equal to 0.3. And like I said, you could have it be 0.8. It can be anything. It could be same autonomous level of consumption. In this country, state, family, person, household, whatever, every single additional dollar of income they're going to spend 30 cents, they're going to save 70 cents. In this one, every single additional dollar they're going to spend 80 cents. They're going to save 20 cents. So these numbers right here are one of the things that economists want to know. We want to know, okay, when we give people the tax break stuff that they're talking about right now, when you give people $100 billion more dollars, how much more does consumption go up by? Does it go up by 90 billion, or does it go up by 60 billion, or does it go up by 30 billion? Because the size of these numbers has implications for the types of policies that we want to do and how effective they're going to be. Once again, this is the more complicated model. We're on the easy stuff of the complicated model. Okay? It's like the little virus thing that goes around when you start feeling your stomach starting to be like, ooh, I don't feel too good, right? It's going to get worse before it gets better, right? Questions? So let's look at the average propensity to consume and the average propensity to save. Once again, just going back and using mathy stuff. X, Y. Some function. Can be anything. You guys remember what array is? From probably 4th or 5th grade math. It starts at a point and goes out, right? Now just choose any point that you want to on here. Any point that you want to. I'm going to choose this point right here. For no particular reason. Here's a ray that comes out of the origin and intersects with this point. Okay? This guy has some slope, whatever this guy is, defined by y2, x2. Right? The slope of this ray is the average value. Right? Because that's what average is. Y over x, right? Take all of the money that everybody has in here, add all that up, divide by the number of students. Total amount of dollars divided by the total number of students. Here's our students. Here's money that you have in your wallet right now, right? How would we find the average amount of money that people have in their wallet right now? Well, the total dollars divided by the total students, y2, x2, right? The slope of this ray is the value of the average, and that's true for everything. Once again, that's nothing to do with math. I mean, that's nothing to do with economics. That's just math. Same thing over here. Here's some ray, right? not 45. Not 45. Same thing over here, x3, y3. The slope of this guy, the ray slope, is the average. So on our function over here, remember there's only two different things that we can do with our income. We can spend it or we can save it. So here's our income. Here's our consumption. Here's our 45-degree line. Here's our consumption function. The slope of this guy is our marginal propensity to consume, but we've got a ray that could be anything. We could choose any point on here that we want it to be. This is just some ray. And the slope of this ray is the average. Well, since we're talking about consumption, here's income, here's consumption. What's average consumption per dollar? Well, that's just C divided by Y. Here's your rising. Here's your running. Right, that's what slope is. Slope is rise over run. So this tells us our average propensity. To consume. So here's our APC. This is just consumption over income. Consumption over income. There's only two things we can do with our income. So we've got our average propensity to save. APS. That's just S divided by Y. Our savings divided by our income. And just like the MPC and the MPS have to be equal to 1, what do you think is true about the APC and the APS? What do you think these guys have to be equal to? They're all equal to 1. There's only two things you can do with your money. You can consume it or you can save it. What else could you do with it? There's no black hole it goes into. There's no black hole it comes out of, right? It's either spent or it's saved. Okay, we'll pick it up from here on Monday.